All right, this video is about chapter 7.4, dividing polynomials. So the first process for dividing polynomials is if you had a polynomial like 10x cubed minus 5x squared plus 20x, and you were dividing by a monomial, which means a single term polynomial. And the way we're going to do this, which you guys have seen before, is that we're going to divide 5x into each term above. Because really it's as if you're trying to determine if you can factor out the term 5x from the numerator. So when I divide 5x into the first term, I'm going to get 2x squared. When I divide 5x into negative 5x squared, I'm going to get negative x. And 20x divided by 5x is plus 4. So this is the polynomial you get when you divide that original polynomial by 5x. Okay, now we're going to practice dividing a polynomial by a binomial. That means where there are two terms. And one of the main ways to do that is through what's called long division. So if you have long division, we're going to take x plus 2. This is pretty much like what you learned when you learned long division way back when. And I'm going to divide that into the polynomial 2x squared minus x minus 10. All right, I'm going to look at the first term here and see what it can divide into over here on the right. And I can see that x can go into 2x squared, and it can divide in 2x times. So if I divide x into 2x squared, it goes in 2x. And so I'm going to put 2x over the term that has x because those have the same power. So now just like when we used to do long division, I take what I just put in on top of the division bar, I multiply it by what's on the outside. So 2x times x is 2x squared, and 2x times 2 is plus 4x. Then I subtract, and again, you're subtracting this entire expression, again, just like you did when you were doing long division as a young math student. So this is going to cancel. Negative x minus 4x is negative 5x. I carry down the negative 10. X divides into negative 5x, negative 5 times. I multiply this by x plus 2. That is negative 5x minus 10. I'm going to subtract that entire expression, and when I do, I get 0, and this is the remainder. Since my remainder is 0, that tells me that this divided in evenly, and it tells me a couple of other things. I know that if I were to multiply x plus 2 times 2x minus 5, I would get 2x squared minus x minus 10, right? So that's what I just found out. I found out that x plus 2 is a factor of 2x squared minus x minus 10. I found out how I could rewrite that polynomial as the product of two factors. Okay, let's try another one. So I have 2x plus 1 on the outside, dividing into 6x squared plus 7x plus 2. All right, I say, does 2x go into 6x squared? The answer is yes. It goes in 3x times. And so, sorry, hang on a second. It goes in 3x times, so I write 3x and I write it above the term with the same power. I multiply 3x times 2x plus 1, that is 6x squared plus 3x. I subtract the entire thing. This should cancel. 7x minus 3x is 4x. I carry down the plus 2. Does 2x divide into 4x? Yes, plus 2 times. 2 times 2x is 4x. 2 times 1 is plus 2. I subtract the entire thing. I get 0 again, so that shows me that this was in fact a factor, and when I divide them, I'm left with 3x plus 2. All right, so things are going to look a little different in this one. Notice that I'm dividing by x squared minus 1, and that's missing the x term, so I'm going to put a placeholder in there of 0x. And the same thing when I have my polynomial I'm dividing into, it is missing an x squared term. So I'm going to put in a 0 for that. Okay, it will make your math easier if you have these line up. All right, I'm going to take x squared, and I say, does x squared divide into 3x to the fourth? It does. It goes in 3x squared times. So again, I'm going to put 3x squared over here. Part of the reason why I do that is to make sure I don't forget any terms. So it's helpful for me to do that. So now I take 3x squared and I multiply it by all of these. 3x squared times x squared is 3x to the fourth. 3x squared times 0x is 0x. You could have a plus or a minus. 0x cubed, excuse me. And then minus 3x squared. Again, you are subtracting the entire thing, so make sure you have parentheses so you're ready to distribute that negative. These will cancel. 2x cubed plus 3x squared. I bring down the next term. So now I say, all right, does x squared divide into 2x cubed? It does, with a plus 2x. Now I multiply that by what's on the outside. That's 2x cubed plus 0x squared minus 2x. I'm going to subtract this entire thing. When I do, these cancel. I have 3x squared minus 6.
That. Could you try?
Oops. Sorry about that. Sorry. 3x squared minus 6x. I bring down the plus 6. Does x squared go into 3x squared? Yes. Plus 3 times. So I multiply again. That's 3x squared plus 0x minus 3. I subtract. These will cancel. I'm left with negative 6x plus 0, actually, because, sorry, not plus 0, plus 9. Okay, so a couple of things. This is my remainder, right? And so that tells me that x squared minus 1 is not a factor. This is called the quotient. So that's what I found when I did my division. And if you want to write your answer as the full quotient plus remainder, the way you would write it is you write the quotient that you got up above, plus, and then you put your remainder as a fraction over your divisor, which was out here, okay? The reason you can do that, I'm just going to add a page here to do an old, like, fashioned example. Let's say you had let's say you had 4 into 25. 4 goes into 25 6 times with a remainder of 1. And so you could say that your answer to this is 6 plus your remainder of 1 over your divisor of 4. In other words, 6.25. And that is what you would get if you had changed it into decimals and kind of kept going. So that's the reason that this works when we're doing on the long division. Okay. All right, let's take a look at number 7. Let's see, is this a good one for us to do? This is similar to what we were just working on because it has places where you need to use placeholders. So that's something to keep in mind when you do that. Let's take a look at number 8. It's kind of an exaggerated version of this. So if I was doing x to the 5th minus 32, I would need lots of placeholders. 0x to the 4th, 0x to the 3rd, 0x squared, 0x minus 32. And my divisor out here is x minus 2. So I say, all right, does x go into x to the 5th? It does. X to the 4th times. So again, I write that over that same power. I multiply x to the 4th times x minus 2. And then I subtract this whole thing. That's going to be 2x to the 4th. And I bring down the next term. X goes into 2x to the 4th plus 2x to the 3rd times. Again, I multiply 2x to the 4th minus 4x cubed. Subtract this entire thing, and I'm left with 4x cubed. Bring down the next one. X goes into 4x cubed plus 4x squared times. So this is 4x cubed minus 8x squared. I subtract the whole thing. So I have 8x squared. Bring down the next one. Excuse me that I'm going to go over this now. So now I say, does x go into 8x squared? It does. I have to multiply it by 8x. So this is 8x squared minus 16x. I subtract the whole thing. So this is 16x. I bring down the next piece. X goes into 16x 16 times. And when I multiply, I actually get that I do have a remainder of 0. Notice what it said. If it is, write p of x, that was this, as a factor of the two factors. So I just found out that x minus 2 is a factor, and in order to get to where I originally started, I'm going to multiply it by the quotient, which is this. That's supposed to be plus 16 at the end. I ran out of space. That's a long one. So in other words, we're taking the polynomial that we were originally dividing and we're writing it as a product of two factors because it went in evenly. Okay, so now we're going to learn something called synthetic division. So long division should always work. Obviously, at times it is long. And let's see how we can maybe find a shortcut for very particular examples. So let's do this one out the long way. X plus 3 dividing into 2x cubed plus 10x squared plus 0x. That was nice of them to give us the placeholder so we didn't forget. X goes into 2x cubed, 2x squared times. So I multiply. This is 2x cubed plus 6x squared. I subtract. When I subtract, I get 4x squared. Bring down the next term. X goes into 4x squared plus 4x times. I multiply. 4x squared plus 12x. I subtract. This is negative 12x. Bring down the last term. X goes into negative 12x, negative 12 times. That's negative 12x minus 36. I'm going to subtract that whole thing. It's going to have a remainder of 24. Okay, so what synthetic division is going to allow us to do is to do the same problem. You can use it whenever you are dividing by a linear expression that looks like this, x minus a. And this is the procedure for how you're going to use it. I'm dividing this by x plus 3. So I'm going to put the root in the corner. In other words, if x plus 3 was a root, you would solve that and it would be x equals negative 3. Okay, so the root goes in the corner. Across the top goes the coefficients of the polynomial you're dividing into. 2, 3, you still need a placeholder for 0x, and negative 12. Okay, so the root is in the corner. Excuse me, it shouldn't be 2. It should be negative 3. The root is in the corner, and then the coefficients of the polynomial you're dividing into are across the top. Okay, here's the procedure. You bring the first number down. You multiply with the number that's in the corner. You put the product here, and then you add going down. Except again, I put these numbers in the wrong spots. I'm not really sure why. Apologies for that. This should be 2, 10, 0, negative 12. Okay, sorry about that. Okay. So now that I multiplied, I write in my negative 6. Now I add going down. 10 minus 6 is 4. Again, multiply by what's in the corner. That's negative 12. I add going down. Multiply by what's in the corner. I add going down. Now, what you hopefully will notice is a few things. Compare this to the long division I did before. This number is the same thing we found up above to be your remainder. So I now know that x plus 3 is not a factor of this polynomial. Notice what these numbers represent. They represent the coefficients of your quotient or your answer when you did the long division. So now if I want to find out what that quotient is, I have a couple of choices. My polynomial originally was a cubic, and I've now divided it by x. So I know that I've lost 1 degree. So I know that this is 2x squared plus 4x plus negative 12. Okay, in other words, you've lost a degree and then you work your way down each degree. The other way to do it, which you might find easier or that it always works, is here's the remainder. Now start from here, reading towards the left, and add a degree each time. So this will be my constant. I add a degree, I get 4x. I add a degree, I get 2x squared. Okay, either way, I know that this is my quotient and this is my remainder. And again, it's hopefully you're seeing much faster than long division. All right, let's try another one. I know I can use synthetic division because I'm dividing by a linear term like this. I put the root in the corner. The root here is -2. I put the coefficients of the polynomial that I'm dividing by across the top. I bring the first number down. I multiply what I just brought down by the number in the corner, and I write it here. Now I add. Multiply by the number in the corner. Now I add. Multiply by the number in the corner. Now I add. Except again, I think I'm making mistakes here. So let's see, that's going to be 10, 12, it's 220, -220. That's my remainder. So my remainder is -220. My quotient comes from these. So again, a couple of choices. I know I started off as a cubic, so my answer is going to be quadratic. Or start with the constant and work your way up 1 degree each time. All right, well, let's do one more example. This is linear binomial, so I can put the root in the corner. I put the coefficients across the top. Notice I need a placeholder for the one that's missing, which is x squared. I bring this number down. Multiply by what's in the corner, add. Multiply by what's in the corner, add. Multiply by what's in the corner, add. My remainder is 0. That means that this is a factor. And so look what this means. This quotient is x squared plus 7x minus 8, which means that my original polynomial, p of x, could be written as being equal to x squared plus 7x minus 8 times x minus 7. In other words, I've just basically factored this, which is kind of neat. All right, finally, one more thing that synthetic division is really useful for is by applying what's called the remainder theorem. So what the remainder theorem says is that if you divide a polynomial by x minus a, like we've just been doing, then whatever you get as the remainder is also happens to be equal to that polynomial being evaluated at e. So let's see what that means. I'm given a polynomial. I'm asked for p of 3. We know that p of 3 means plug in 3 wherever you see an x. But this would involve some math, and some of these numbers get kind of big, and I'm not allowed to use a calculator. So a nice way to do this is to actually do synthetic division. If I want p of 3, 3 is the root, so I'd put 3 in the corner. I now put my coefficients across the top. Notice that I need a placeholder for a couple of these spots because it's missing an x to the 4th and it's missing an x. Now I do synthetic division. I bring this number down. Multiply by what's in the corner and add. Multiply by what's in the corner and add. Multiply by what's in the corner, add. Multiply by what's in the corner, add. Multiply by what's in the corner, add. This is the remainder, which happens to also, in this case, equal p of 3. So we just were able to find p of 3 without doing, that exact kind of math that was going to maybe take us a little bit of mathematical effort.